All right, so the Word file called On-Site Psychometrics Day is going to walk through how to run an exploratory factor analysis in SPSS using a historical data set on young schoolboys in Great Britain and their scores on their exams in maths, calculus, history, probability, Gaelic, and algebra. So this was in Ireland, huh? So these are 10 young men. You can see each row represents a student and their grades in 1, 2, 3, 4, 5, 6 subject areas. Okay. So the first thing you do is open up your SPSS file, and it looks like this. The SPSS is here. The file is called Verbal Chromex, and here's those scores for these 10 young gentlemen in their 6 areas that they were taking their exams in. So you see here, there's 2 extra columns, and this is for later on and for other podcasts, just to show you how to come up with a visual analog scale and also to compute an average intelligence on these 6 areas. Okay, so we're focusing on these 6 columns for the beginning of this exercise. All right. Next, you're going to run descriptives on these. So you're going to run descriptives on those 6 exam scores for those 10 young gentlemen by going to Analyze, Descriptives, and Frequencies. You can go to Analyze, Descriptives, and pull over those 6 variables of interest, which are those scores on maps, calculus, history, probability, Irish, which is Gaelic, and algebra, and get measures of central tendency, their mean, and measures of variance, standard deviation, standard error, the mean, min, max. This is output that you get, which would be if you're on syntax or code, you would see this, but you're going to do it using a graphical user interface typically, which means point and click. So analyze, descriptives, frequencies, pull over only the 6 you're interested in. So these are going back. And you want to get their mean, you can get median, get whatever you want. I mean, this is you looking at your data. It's actually an item analysis that you're doing. And you can pick what you want. I'm only going to get the standard deviation because if I square it, I get the variance statistic and get a min max, which will give me the range. You can also get skewness and kurtosis statistics if you want to see are your data normally distributed. Same thing, get some pictures worth 1,000 words. Remember, there's only a sample size of 10 here, so I'd assume we might not, the normal distribution, right? Hit OK. And you get your output. So you see I ran mine with some different descriptive statistics than what are in the on-site psychometrics days, but at this point, you should be experienced enough with looking at measures of central tendency, mean, median, mode, and measures of dispersion like standard deviation, range, standard error, the mean, variance measures that you can look at these and pick the ones that you want to look at for item analysis. So here are the basics. You can see we have no missing data because there's an N of 10 for each of the variables we're interested in, their scores on exams. We get a min max, we get a mean, we get the measures of dispersion around that. It's a way for you to actually look at the items and see, hey, you know, does this look okay? Do they look like there's 2 different subpopulations in here? And the pictures give you the same kind of output. So you can see it doesn't look normally distributed. You only have an N of 10. Some of these look like you might have a bimodal distribution. I'm just going to orient you to one of these. Again, just remind about reading bar graphs or histograms. Here's the normal curve that's imposed over it. Obviously, it's just a standard normal curve. But when you look at this, for this one here on calculus, you could see for the 50 to 60 score, 1 child. For the 60 to 80 score, you have 2 kids getting between 60 and 70 and 2 between 70 and 80, right? We're using the y-axis for the frequency and the x-axis for the actual number of the score. And over here, you get the mean and the standard deviation and the sample size itself. Okay. You always want to look at your data first, right? Look at descriptives before you actually do inferentials or any type of further analysis to see if your data meets assumptions that you might need later on. Okay. So these are just the actual frequency tables. Here's your descriptive statistics in one overall table. And next you're going to run correlations. Okay. So for correlations, it would be, and why would you be doing that? Let's think about it. If you're going to be doing a factor analysis later, you wouldn't want to do a factor analysis if you truly didn't think some of the items were correlated with each other, right? So you're going to run a correlation and take a look and see indeed are some of these items correlated, meaning does it look like they might be measuring the same construct overall or some of the same subconstructs, some items measuring, some of the constructs, subconstructs. For example, here, intelligence or more likely achievement in these areas of maps, calculus, Gaelic, algebra, probability, okay, and geography, okay, history. All right, so to do it, you would go to analyze, correlate, bivariate, right? Because it's a bivariate statistic. So let's do that. And the screenshot's right there. So it's analyze, correlate, bivariate, because there are two, right, that we're going to do, correlating two items. What I'm doing is just controlling, bringing them all over, and then I'm taking out what's not included in the analysis, the analog and the average, because we only want to correlate the items that we're going to put into the exploratory factor analysis later. The default in SPSS is a Pearson's R, which is used for two continuous variables, which works for us. We're asking it to flag significant correlations, and we're doing a two-tailed test. And over here in our tab, we can go right to correlations. And here we go. So map is correlated with calculus negatively, right? Meaning it's 1-1 up. The scores and overall for this sample of 10 students, as map score went up or down, calculus went in the other direction. Remember, correlations can go from -1 to +1. So for a small sample size and just scores obtained, it's pretty significant, I think, but it's probably not going to hit significance with a two-tailed test with a sample of 10, and it does not. The p-value associated with this statistic here is a 0.142, so it is not significant at a two-tailed test. It's not crossing the 0.05 alpha threshold we've set, and the sample size is 10. You're not going to always see this output depending on different programs that you use to do your statistical analysis. This is how SPSS sets it up. You will note that you have two of the statistics estimating the correlation between calculus and maps, because it runs it both ways for you. So you really only have to read one side of this. So you use the diagonal here, the ones, and you can cut, like, don't read one whole half of it, just read the bottom because it's a repetition of information. Okay. So as you're looking at that, it does just look at maps first. Looks like maps is negatively correlated with calculus and probability and algebra. So maybe it's measuring a different type of aptitude besides, or achievement actually, besides these. And algebra and probability and calculus could be grouped into quant, right? So if you come then to calculus, you can see that calculus is significantly, with a good magnitude, 0.814 correlated with probability, and also with algebra, 0.836, right? Makes sense. So if it comes across to algebra, we see the same thing. Algebra is strongly correlated with probability, 0.937, nearly a 1. So what this is telling us is perhaps within this overall intelligence, achievement, aptitude, whatever school you're in is regarding intelligence, and whether it's a fixed absolute measure or one that can change, regardless of what you want to call it, it looks like there might be two things. One being quant, and the others Gaelic, history, and maps, perhaps representing something else. Okay, here's history. It's only correlated with maps. Here's Gaelic, strongly correlated with maps, and really not strongly correlated with anything else. Interesting. Okay, so it tells us, yeah, we might have, 2 or 3 subconstructs here. Let's see what's going on. So that's our correlations. And go back to our Word document. Look at this. We looked at our output. And when that's done and you interpreted and looked at your correlations, like, again, looking around for a little background information, you're going to run your Chromeback's alpha if applicable, meaning you're going to run it, for us it is applicable, where our assumption here, our hypothesis is that we have some underlying overall scale, whether you want to call it intelligence, aptitude, or achievement. So we're going to run a 6-item Chromebax on the whole scale, and then we're going to run it on what we're thinking might be quant and verbal. Okay. So there is a handout on how to run Chromebax and SPSS. You should have learned this prior, right? So here it is. It's a nice little tutorial on how to, and this gives you a lot of background information on how to run a Chromebax. And there is a different data set using the Chromebax here, and what it means and how to look at it step by step. I wanted you to have that for review, how to interpret it, but here's your Chromebax. So you go to, let me just move this over, analyze, scale, reliability analysis. We're going to do the whole scale, so pull it over and take these out, because the only thing that's part of this scale is those 6. So it's total scale. Total of 6 items. And it might be named slightly different in the handout. It's the same thing. We want to look at the item, the scale, the descriptors for that, and the scale if deleted. Again, looking at the descriptors for the item is the same thing that we did already, right? We did our, you can run inter-item correlations. Again, a repetition of what we did in the first descriptives and correlations, but it's what it is. What we really want to know is the scale itself, summaries of the means, variances, correlations. Correlation is a standardized covariance, so we want that. Hit it and go. We get a lot of information. Come over here to our reliability, and what's it telling us? Okay. The Chromebax is a 0.364, so it's not so hot, right? Chromebax, you want it above a 0.7 for a pilot instrument, above a 0.8 or 0.85 for a accepted instrument. So this looks like it's not so hot for this, right? And next one we're going to run is the one. So it's telling you that we have a negative value. It violates the assumption for running the Chromebax, meaning we already knew from the correlations that they were all, but there were some negative correlations. So there is no, that underlying construct is not going to be there, but we knew that. And wanted to see what the scale looked like and what it looks like if you delete items. So it looks like we have 2 different sub-constructs here, which is fine. This will happen with your scales too. So let's go to analyze, scale, and run it on the smaller scales, you know, on the subscales. So the next one in your handout, we're running it on the quant, and then we run it on the verbal. Okay, great. So analyze, scale, reliability. I'm going to run on the quant first. I'm going to take maps, history, and Galen out of here, and I'm going to call it quant. Same things on the default, and then I'm going to run it now on the, get you out of here, run it on the verbal, analyze, scale, reliability, and it's going to be on the verbal. What we're assuming is verbal might not be. Maps, scale, history, change the name to verbal. You see it remembers in SPSS your last choices. Let's look at our output now. Okay. So I'm going to give you the full output, okay? It's telling you those selected screenshots are you get that 0.945, which is really high for 3 items, right? Wow. For the quant, for those 3 items, and the verbal, we're getting 0.7. I want to show you the full output here. And what it's telling us here is that 0.945. It's only 3 items. That's really fantastic for 3 items, right? It's all about parsimony, and only 3 items you're getting that. Because remember, as you add more items, the Chromebax is artificially inflated, even if the items are not perfectly correlated or correlated at all when you get to a certain number. But here you go. My favorite thing to look at. Then you get a nice, again, your descriptives on each items, right? But if you look at it here, the Chromebax alpha, if you deleted that item. So if I got rid of algebra, there'll be a lower Chromebax, right? If I got between those two. So they're still great, these Chromebax, which is showing you how well correlated they are and the strength of each item in the subscale. When we get to verbal, it's a much lower Chromebax, meaning that they're not, I mean, it's 0.7, which isn't horrible at all for 3 items, but it's much lower than that insanely high great Chromebax we have with those 3, which tells us those 3 items are measuring, they're tapping into a similar construct, subconstruct. And these guys, what here? If you got rid of maps, the Chromebax alpha in history and Gallic would only be a 0.2. So it's like maps kind of holds them together. They're tapping into some same subconstruct that maps is a very strong item for. If you got rid of history, Gallic and maps would have one of 0.806. It's amazing. So it's telling you that they're strongly correlated. So it's important to look at that, meaning that here, something different's going on. Maps is bringing something into the picture that taps into some subconstruct that history and Gallic also have. But they also have some variants, some things that contribute to the variance of the construct you're trying to get at with each of those individual items, okay? Let's go back to your handout. We are now on page 14, which is how to run an exploratory factor analysis. So that goes from page 14 to the rest of the handout. This is going to be your first podcast. Let me just pause and see time. I think this will be the first podcast for the background runs. I do it on these data, the data I gave you, and you can also then run it on your own if you have already collected. If we were in the workshop day, you would do it on these data, and now here would be the break time. You run it on these data, this data set I gave you of the schoolboys' grades, so it's N of 10 on 6, and then you would run it on your own data to see if you could replicate it, you know, with the same screenshots. Of course, different output you'd get, but just to try that. So this will be podcast 1 for on-site psychometrics day for EFA, and EFA will be podcast 2. So I think that's how we're gonna leave that one.